You can't see the beam itself. The laser light is being emitted in the invisible infrared region of the spectrum. Kirkland's staff study the effects of high-powered lasers on target materials.
For instance, if someone said, we'd like to see what a laser could do to a satellite, we would evaluate the different parts of that satellite to determine how we could damage it.
The laser at Kirkland doesn't usually use enough power to blow things up. It just burns them.
It depends on how much power that you put onto the target. You could make a very small sized shot, put tons and tons of power into it, and you're going to have a higher heating rate on that target.
But this is just a small laboratory laser. The US Air Force is working on a far larger and more powerful laser, and it flies.
The airborne laser is a 747 airplane. It's a jumbo jet that we put a very sophisticated optical system in the aircraft, a battle management or command and control system, and high energy lasers in the back of that. So think of an airborne laser as a jumbo jet that has a beam of light that comes out the nose of the airplane that can be directed onto a boosting ballistic missile to destroy it.
The airborne laser began as an Air Force program to shoot down short-range missiles. In 2001, it became part of the Missile Defense Program. Its job is to destroy medium and even intercontinental ballistic missiles. Infrared cameras are designed to detect a missile launch. Detection information is passed to onboard computers, which direct a turret in the nose of the aircraft toward the missile. The turret uses two sets of lasers, one to lock on the target, the other to fire and destroy it. With a range of several hundred miles, a handful of these weapons deployed in hot zones would be a powerful defense.
And what the airborne laser actually does is we have a deformable mirror in the optics train, and that mirror is used to pre-distort the high-energy laser beam. So basically the atmospheric effects between the airplane and the missile are taken out by that pre-distorted beam. Sounds a little like science fiction, but it's actually a concept that's used every day in observatories around the world. Much of that work is done here at Kirtland Air Force Base, so that's a very well-proven technology.
Very impressive, but still light years behind the blaster we have on this ship. And these aren't even the big guns. Remember antimatter, the stuff that combines explosively with matter to produce utter annihilation. Our alien ship supplements its laser weapons with an antimatter torpedo. There's no ignoring the fact that the alien ship bristles with offensive weapons, but are there any defensive ones? Our engineers believe they've found a device that generates a force field shield. A shield that deflects or absorbs an enemy blow is an almost perfect defense. But what about a shield that renders you invisible?
Many witnesses will report seeing the craft as clear as a truck on the street in broad daylight, and as it's flying away, or even as it's approaching, suddenly it's just not there. They wink, they blink, they pinch themselves. It's gone.
It could be that the ship's instantaneous acceleration just made it look as though it had disappeared. This is not the case with ours. Among the defense mechanisms on our alien spaceship is a cloaking device, perfect for escaping from dangerous situations. Okay, so it's not perfect, but it's a lot better than anything we humans have been able to produce.
When light hits an object, it excites the atoms, and the atoms then re-radiate. If you want invisibility, that requires controlling the atomic structure of the atom itself. No one knows how to do that.
In fact, some of our fellow inhabitants on Earth seem to do a better job of disappearing than we do.
There are animals which can change their coloration depending on the background they're up against. Chameleons are, of course, very well known. There are some flatfish that can do this also, tiny freshwater sole, which have both eyes on the same side of their head. But if you put them on a bottom which has got any particular pattern, they'll realign their coloration to match that.
The flounder performs its disappearing act thanks to chromatophores, special cells containing pigment granules that enable the organism to change color.
A really striking experiment, somebody tried putting these things on top of a square checkerboard type pattern. And they couldn't match it exactly, but they came real close. The edges of the black squares were somewhat rough, the spacing was correct, and they were approximately square.
Camouflage isn't the same as invisibility, but it can achieve similar results.
If you electrify a piece of cloth and put sensors in the system so that it can, in effect, see, you could presumably change the cloth coloring to match the background in an active way, if you had a little computer to do it.
Invisibility is a nice option. The alien ship also has a force field among its defenses. The force field generator is even capable of repelling laser weapons. However, force field shields and cloaking devices aren't the exclusive domain of alien engineers. The US Department of Defense is undertaking R&D to turn science fiction into science fact. Here at Old Dominion University in Virginia, Munir Larousi is at the forefront of cold plasma research. Plasma might one day hold the key to futuristic defensive weaponry once limited to sci-fi movies.
This very well could be the force field or the cloaking device of the future, somehow similar to, what people have dreamt about in Star Trek.
But what actually is plasma?
Matter comes in 4 known states. The solid state, and then you heat it, and you get the liquid state. And then you heat that, and you get the gaseous state. And if you keep on heating that, some of the molecules and atoms get stripped from the electrons and then become ionized. When it becomes like this, we call it plasma.
"99% of visible matter in the universe may be plasma, including stars. And it comes in natural and man-made varieties.
In nature, when you have a storm and you get lightning, that light you see that comes from the plasma, that's air breaking down because of the high voltages between the cloud and the ground. It's man-made in neon lights and fluorescent lights. Inside of those, the gas is broken down into the state of plasma.
Dr. Larousi's device generates a plasma plume by applying voltage between 2 disc-shaped electrodes in the presence of helium gas. The US Air Force provides some of Dr. Larousi's funding. Their hope is that in the future, cold plasma technology could provide the fabled cloaking devices and force field shields seen on TV.
We are trying also to apply plasma in a different kind of setting, so the plasma can play a role of a shield or of a mirror to bounce off electromagnetic waves. Instead of having a really solid material that is there, When the plasma is switched off, there is nothing. Then you switch on the plasma, and then the plasma will act as a mirror that you can bounce electromagnetic waves from.
LaRusse hasn't